Twitter. It'll probably, yeah. Now it says we're live in the quarter, so I think we are live.
Awesome.
Just want to get the link. Yeah, we're good. Okay. Well, Yush, man, thank you for joining us. It is great to have you here. I had a really great time chatting with you back in Denver and hearing about. Okay. I think audio was coming through from somewhere else. Yeah, as I was saying, had a really great time chatting with you in Denver, and we've been trying our best to help share with our community and with the broader crypto ecosystem more ideas around how you can use ZK to build new products and provide new user experiences that this technology enables. So really happy to have you here on the stream. While I posted a few links in some places, I figured I'll just give you the floor to introduce yourself and ZK email, and we can take it from there.
Yeah, totally. Sweet. Yeah, so I'm Yush, and I've been working on ZK email now for a few years. The idea is that it's kind of both very interesting research-wise of how can you make, redacted email proofs fast, and very interesting product-wise in the sense that it unlocks a lot of things that weren't possible before, both on and off chain. And so, yeah, it's kind of the main thing I'm excited to chat about. I think, crypto apps so far have been quite siloed and kind of remain within crypto and DeFi people. And I think there's a real opportunity here to expand that a little bit more. So, yeah. Excited to chat about that stuff. Should I just get into the slides?
Yeah, jump into it. I'm just sharing the link in one more chat to kind of amplify the message. But please go ahead.
Yeah. I'll just start with kind of the high level stuff. Okay, cool. So the main idea behind ZK email is that how do we even get these powerful proofs to work? Well, the idea is to start with an asymmetric signature. So we start with every email that you have sent or received since 2017 likely has an RSA signature on it, even though you don't know about it from your existing inbox. And this is specifically the sender will have an RSA public key and make an RSA signature from their domain of all the information in the email. That is the SHA-256 of the from, the to, the subject, the information of the body, etc. Often the timestamp. And the idea is, this is usually used for spam prevention. The recipient will verify it on their end and say, this actually came from the sender. If so, allow it to pass. But we can hijack that and we can use it for something else, which is basically, we can stuff this entire verification into a ZK proof. Now we can verify the RSA signature of the SHA-256, and we can selectively reveal information by using a ZK regex compiler that we created. And that allows us to selectively disclose information in an email. It's quite interesting because it gives us what we call private programmably provenant proofs. Okay, what does this mean? We can get provenance, so it's directly coming from the Web2 mail server directly. We don't necessarily have to verify via an intermediary or permission set of notaries. Anybody can verify this data, and so it can be totally decentralized. We can extract information via ZK regex, so it can be kind of, we can kind of program our privacy. Say, oh, I want to reveal lots of stuff. I want to reveal a little bit of stuff. We can define exactly what our parameters for privacy should be. We can keep everything private if we want to. And then the final thing we can do is we can verify directly on chain. And this is part of where, I think interesting new verification methods like aligned come in. Cool. So I guess I can go over a couple like high level use cases we've already seen people define, and then I can kind of dive into some, more out there ideas. And hopefully this, serves to mostly just inspire people who just kind of are thinking, okay, what's even possible with ZK tech? Is it really just rollups or is there other stuff you can do? And so, okay, if you think about proving redacted emails, the most simple thing you can do is whistleblowing. You can take, I say simple, but it's actually, quite compelling in the sense that I can say, okay, look, I have this email from this person, in this case, it's from this government.com, and I'm going to redact, my identity from the entire thing, but I'm still going to be able to leak the rest of the information in the email. Or I could do something even more, which is I redact all the information in the email, and I just reveal the domain. And now I can say, look, I own an @gov.com domain. I'm going to say this thing, and you can now have this kind of like anonymous speech. And that's kind of interesting. You can do also kind of on the other end of complexity, arbitrary marketplaces on top of email. So I can say, for instance, I got a Namecheap transfer email, because every time you transfer a domain, you get a confirmation email. And what you can do now is, because you got an email, you can build a marketplace on top of this. I can say, hey, I'm going to escrow some money in order to buy a certain domain. And when the user transfers the domain, the only way they can claim their money is if either one of you provides a proof that the domain was actually transferred. It's quite interesting, because now you can build these decentralized marketplaces with, instead of a third-party escrow, a smart contract escrow. Now there's only 2 parties involved, and all security is done via ZK email, which is really quite compelling.
I wanted to say this is really cool, because I got distracted and I started looking at some domains on Namecheap yesterday.
Yeah.
I had some ideas, and I was thinking about this exactly. I'd forgotten about this example you showed in Denver, but I was thinking, okay, cool. So I can make an offer to somebody to buy this domain, but then I guess this goes through Namecheap, and I didn't even try clicking the button because I didn't want to think about it. But this is a really cool example. And I guess this could be anything, really, right? Like it's like an arbitrary.
It could be totally arbitrary. So like ZK P2P used to do this with like Venmo emails, where they would say, okay, if you can prove you had a Venmo transaction, now you can get money on chain. And so they built like this on-ramp, off-ramp from Web2 payment services. And that's also very interesting. You can have this permissionless, almost on-ramp, off-ramp. And it can be as dumb as like, I'm going to Venmo some account, and now I'm going to get money in my on-chain account. It's like the holy grail of onboarding into crypto.
So you don't have to do any extra KYC,
No. So the idea is Venmo already kind of KYC. They say, oh, do you have a USA bank account? If so, and a USA phone number. If so, then we'll let you make a Venmo account. And so it's kind of like, you're already being KYC by most of these payment apps to some extent, but no, you don't have to do a separate KYC, which is the exciting part.
Yeah, it's interesting because I'm actually about to release an article about decentralized off-ramps. I guess permissionless off-ramps this week, because somebody built one with ZK in our hackathon, and there's actually no other ones that are existent. I tried to look into it a bit, but besides ZK P2P, there aren't any real solutions for this, literally.
Yeah,
so it's an interesting
insane
topic.
Yeah, no, I agree. Okay, so what else can you do? So kind of, I've talked about like the kind of range of examples. Like, okay, we can make kind of simple proofs, we can build marketplaces on top of them, but what are all the emails we can prove? The idea is we put up this little registry. You can scan a QR code with your phone if you want to check it out. And the idea is we have all these different proofs you can make proofs of. Like, on the right, you can see like a preview. You can prove you have a Twitter account. You can prove you merged a GitHub PR. You can prove you were accepted to do a residency. You got an acceptance email for a talk, kind of whatever you want to dream of. And you can define your own new proof as well. So I can say, look, I see this email in my inbox. I want to be able to make a proof of that. You can say, okay, I'm going to click, create blueprint on the top right once I've signed in. And now I'm going to, say, okay, I'm going to define this new kind of proof where I'm going to parse out the handle from the body from any email from x.com. And now you can define exactly what this proof looks like and don't have to think about the backend. We will automatically compile it into Groth16, into SP1, into Noir, and we'll deploy the verifier contract for you, deploy an example website that people can try it out for you, and all you have to do is define these things through the UI, which is quite exciting. And it means we have, like, at this point, more than 100 proofs defined. I give some examples of things that people have defined. You can prove you signed a document with DocuSign or HelloSign. You can prove you took a flight to or from somewhere. You can prove you get from Slack, so you can prove you're part of a Slack workspace. Now you can see where the composability of Ethereum comes into play. You can say, oh, I'm going to prove that I'm part of a Slack workspace, and so now in order to get automatically reimbursed for my flight to this specific place, I'm going to prove I actually booked a ticket and the amount was some certain amount. And now I can build this generic on-chain system where I can prove my identity and get automatically reimbursed and build more and more complex things, like things that we've wanted to build for a long time. And you can prove you did data export. So this is an interesting one for training ML models. You want to train on real human data. How do you prove that somebody's not uploading fake data? Well, you prove, yeah, this is real data that LinkedIn attested to. They're exporting to my inbox. That's pretty exciting. You can prove you exported data from OpenAI. Now you can sell this to people training other models. Like, here's all of my prompting and responses from OpenAI. You can verify they're all valid. Now, Anthropic or whoever else can buy this data and train on it. You can prove you published an NPM package. You can prove you completed a GitHub issue. You can prove you verified KYC. So I can prove, hey, I verified KYC on this centralized exchange. I'm going to now reuse this somewhere else. And it's really exciting because at this point, we've actually had over 5,000 proofs go through this registry, meaning these are like, likely real people making real proofs about their identities that keeps their identities private, which is pretty exciting.
Yush, this really, I mean, every time I see this, I get more and more ideas for what these primitives enable. It's actually, it's very cool. Like this is a way to do Sybil resistance. This is a way to permissionlessly or like let people opt into different services based on real life credentials they have. I mean, it's like thinking about the early days of Facebook. You had to be at one of the schools where it was being piloted, but you could kind of extend this idea. And if you have any .edu email address, you're a university student in the States, you could create this way for those students to opt in to a system that is exclusive to them, or at least exclusive to people who have those email addresses.
And the coolest thing is they can keep them anonymous, which is super awesome. And you can build like all sorts of weird systems, right? Like, for instance, I can take this GitHub issue one, and now I can say build a bounty bot where people, you can comment on a GitHub issue, hey, I'm gonna tip $50 to anybody who merges and solves this issue. And now you can build this thing where when somebody merges a PR that it resolves an issue, that person can automatically get paid. So now you can build a system on top of GitHub where you incentivize people to solve the issues you want to see solved. It's like you can sort of imagine these systems outside of crypto that add a lot of value, just because you can make these kinds of proofs. So, on one side, we've kind of discussed, okay, you scroll through your inbox, you decide you can make all these proofs of emails you see, but there's kind of another side of things, which is very much linked to like really deep on-chain verification. That's making wallets feel like banks. When you interact with your bank, you log in with your email. If you need to confirm a large transaction, you're going to confirm via email. If you lose your account, you can always reset your password, recover your account via email. And we don't quite have that UX in crypto yet, but we could. And the idea is you can actually get each of those things in a crypto wallet. And the way you can do this is you can log in with your email and make exactly a ZK email proof of that one-click sign in with Google login. Then you can confirm email via transaction signer. We built a primitive that lets you add emails as signers onto nodes as safes, now called safe wallets. And you can do account recovery where you can basically say, I'm going to add emails as guardians for my smart wallets. And if I lose my phone or whatever, I can always recover my account if those guardians all agree and a time lock passes.
Clave has that feature. Sorry for interrupting.
No, go ahead.
Clave Wallet has that feature. I think they're the first people who did it also.
Yep. So this is like live on mainnet. Like people, this is exactly a screenshot of the Clave wallet. And you can add, as you can see, your email address as an email guardian. And as long as some quorum of these get together and opt to recover your account, you can always, back up and recover your assets, which is quite exciting because historically people have, lost their phones and their assets are lost forever.
Yush, I have a question.
Claves is not through email, though. By the way, just to
correct. So this just got released literally last week. I don't know if you've tried Clave recently, but we finally released kind of into production last week. So if you access your app, emails should be available as guardians.
Cool.
Yush, this is a bit of maybe a digression, well, sort of from the main presentation you have, but I'm really interested in hearing about the Clave partnership and how that all came together, because that you guys announced that a couple weeks ago or a week ago. Super cool stuff. And I'm wondering what that took. Like I imagine you've been speaking with the team for a long time, but from the DK email's perspective, integrating that, testing it, actually bringing this into production for all of their users in a secure way. I think, well, I'm personally really interested in hearing that story.
It's very interesting because kind of ZK tech in the mainstream secure wallets is a totally different business than, or a totally different deal than, I don't know, doing something like a KYC verification or something where you don't necessarily have these like extremely stringent requirements of Solidity verification on chain. And so, we started talking about this like about a year ago, like, hey, we want to build this feature in, how do we do this? And then we kind of iterated the spec a couple of times. We made it more generic. We found a bunch of security issues because we audited this thing like 4 times. Like it's like really, really secure. And each of the audits we did, we were like, hey, we could maybe redesign this part of it, or hey, maybe we should maybe fix this, or we should redo our circuits, or we should like change how we do the Solidity verification. We added all these security features. Like there's time locks, there's there's generic modules, people can reuse this in any other app. There's, how users see the email and reply to it, the UX of that. There's, in all the emails, now there's like a reply needed kind of field in the subject. So hey, this is an email that if I reply to it, something might get triggered on chain. There's all sorts of guarantees we added. And so really bringing that in production. And we had this like in testnet testing internally, like for almost like 4 to 6 months, and just really iterating, okay, does it work with different email domains? Is it fast? How reliable is it? All this kind of had to get tested. And then over the course of 6 months, we finally iterated on it. And then, now it's finally on mainnet. And so it's kind of, now that we've done this process once, we sort of know what the design of email recovery looks like. And now it's very easy to deploy on new wallets. But really, the first wallet getting onto mainnet, I think, was really like quite a process. Like we hadn't really seen ZK apps in the mainstream other than ZK P2P, to be honest. And so really having this sort of level of security took a while.
That's awesome. Yeah, and I can only imagine like there's probably tons of different edge cases. Like not everyone uses Gmail for their email address. Maybe they're using some funky Proton server or something and hosting it themselves, and all that needs to work. So
they had all these weird quirks, and we've kind of, I think, at this point, like figured out, okay, how do we resolve most of those quirks? Some people still have email servers that aren't signing email, but that's very rare. Like in general, we've seen like more than 99% success rate on email proofs. Cool.
Yeah.
That's great. Yeah, and I guess kind of on the other side of things, how do each of these look like? And we've kind of seen what account recovery looks like. You add your email, you confirm. When you recover, you reply to an email. You can also imagine the same flow for email signers on Safe. So for instance, we add an email address to a Safe. Now that email address can sign on behalf of, if anybody initiates a Safe transaction, the email will automatically get an email say, hey, I just want to confirm this transaction. It's an independent front end, which is really exciting. It just says yes, and now they can confirm that transaction. And it's quite cool because you could have technically avoided the Safe hack if one of those signers was using email, had an independent front end, and said, hey, this simulation doesn't quite check out. Are we sure we want to sign this? That's pretty cool. And this is also live. We have a version of this, and we're kind of just working with Safe to get this integrated ideally.
This is cool. So in this situation, is the email address actually is the signing authority being delegated to the email address, or is it just like it is?
So what we're doing is we're giving that Safe wallet signer a smart contract to whom the authorization can only be passed via a ZK email proof. And so literally you're adding a ZK email verifier contract as a Safe signer.
ZK email verifier contract as a Safe signer. Awesome.
Crazy, right? Yeah.
Yeah. And I guess that can go into any sort of smart contract logic as well.
Yes, exactly.
Yeah.
So we open source this library called Email Transaction Builder, where you can go in and build your own transaction that's dependent on ZK email. Ideally, we use exactly that to build this in like almost like a week or something. It's like it makes all this process like really abstracted away and really easy. And then similarly, like login, you'd imagine this is kind of the eternal problem is connecting a wallet, which most people don't have. You can just hit sign with Google. It'll trigger an arbitrary command on chain. And you can try this live. Like if you scan this, you can literally sign with Google, enter a command, and it'll just execute that kind of like call data on chain. And you can define human parsable values that automatically get parsed by some bespoke on chain logic if you want as well. So apps can really like take advantage of this, which is quite cool.
And JWT is JSON Web Token?
Yes. So when you're signing into Google, for instance, what they will do is they will issue a JSON Web Token, which is now the value we verify within a ZK email style proof.
Okay, cool. So this just enables like really easy, like a social login through this.
Yes,
proof,
exactly.
basically.
To any crypto app, which is crazy.
Cool.
You can be selectively anonymous. You can say, I want to reveal nothing. I want to reveal my domain. I want to reveal that I have an email at one of these 5 domains, whatever you kind of want arbitrarily, which is also quite cool. Sweet. Okay, so now we can transition more to like kind of out there ideas. So, one cool idea is, ZK email lets you verify things about yourself. You can't necessarily take action in the real world. So if you want to take action in the real world, there's really cool ideas. One thing that some of the Flashbot X folks put up is like teleport, which lets you like kind of control your accounts, right? So here's like an idea where someone like makes a deal with this Twitter account. They sign, they delegate like conditional posting access in their account to this specific account, and when they like satisfy or don't satisfy a certain kind of precondition, an action will be taken on behalf of them. You can imagine combining this with ZK email, where now you say, oh, like, if somebody can verify some identity, now an action can get taken in the real world, which is quite cool. Like for instance, if something doesn't verify, then ask them to submit a verification, or if something, they can now say, oh, like, I have to show that I'm part of this institution in order to do this kind of thing, and there's some real world, like almost penalty attached to that, which is quite an interesting experiment. You can use these to build lots of weird things. And we have a bunch of ideas that haven't yet been built on the right side that we invite people to build. If you're curious to build something, it shouldn't take that long to build each thing. We're happy to provide support. You could verify, you can build marketplace on top of restaurant reservations, on top of leaks, on top of donating to papers. There's a lot of like really cool things you can build here that haven't yet really been explored. And you can kind of imagine one step up. You don't just have to make proofs of emails. Anything with an asymmetric signature, you can make proofs of. So kind of, DNS, certain websites are signed, passports are signed, often PDFs you sign on DocuSign are signed, app execution is signed. You can kind of imagine packing any of these into a ZK email style proof, and now you can build an system on top of them and directly interoperate on them on chain, which is quite cool. And you can take even one step further of, okay, well, ZK is cool, but what other advanced cryptography is there? Maybe this is now, exiting what Align is thinking about, but like, there's all these, like, these things are possible because we have advanced cryptography that does do interesting things, but we can go way beyond ZK. We can use, PSI, do private lookups. We can use Trinity, which is witness encryption for private matching. We can use co-snarks to do like private AI training or inference. There's all these really interesting things you can do, and I just want to excite people about there's really interesting possibilities even beyond just ZK email. If you think about really like what other cryptographic printers I want, what exists. Yeah, and if people have more questions, feel free to scan these QR codes. Our Telegram, you can ask questions about the thing. These slides are on the right side, and if you want to actually try and make proofs yourself, you go to zk.email or the QR code on the bottom, and you can actually make these proofs yourself. So yeah.
Amazing, Yush. Thank you. So many cool things to comment on. Before I like start rambling, Jeannie, do you have any things that
Well, I do wonder, like, do you generate these proofs on where? Like, my real question was, do they get verified through Align? No.
Yeah, so let me kind of explain how that works. So the idea is, if you go to the registry, we can generate these proofs either client side or server side. You can kind of select when you say, here you can say, okay, I want to prove I have a Twitter handle. I can either connect my Gmail or drag and drop an email file manually. And then, once I verify the proof, right now we support, both making client side proofs and server side proofs, and then we can support on-chain verification in all sorts of different ways. Right now, we directly verify the proof on-chain with GROT16. But you can imagine if we're doing this at scale on-chain, we probably want like a cheaper method of optimistic verification, in which case something like Align makes a ton more sense, where we have like economic security on the verification, and it happens proactively. I think we haven't yet shipped that into the kind of mainnet version, but it's something we're definitely excited about doing. Yeah,
that's all. Yeah, so I guess right now, like, are you guys just subsidizing the gas fees for users for verification of these cross-chain proofs? Yeah.
So right now, all these verifications are happening. For Clave, it's happening on mainnet, but most of them are happening on testnets, and so you can kind of imagine that. Yeah, like subsidizing just means providing some testnet gas, but yeah, like for people who want to do this in mainnet, we'd imagine either they can pay master or we can provide a paymaster, or they can use something like Align where they batch a bunch of proofs and it all happens at the same time, and now they're paying much less. So yeah, we've just kind of been iterating with folks on what exactly they look like, how much their user willing to pay, how much they're willing to pay for these kind of proofs. Account recovery makes sense, user willing to pay a couple cents to secure their account, but in other contexts, economics might look different. So
yeah, that's something that we've thought a little bit about as well. People building ZK apps, if there is an easy way to allow the user, like the end user, to pay for the transaction and cover that gas, or if it's cheap enough, if you're doing enough at the same time, like say through Align, then maybe the app provider who's hosting it will just take care of that. Again, on testnet, it's not really an issue, but if we imagine millions of users on chain
Yeah.
using mainnet to settle these proofs, then costs definitely become an issue. We actually, I think we tweeted about this earlier. We have like a savings calculator on our website.
Okay.
That
Sick.
just shows, for the proof systems that we have verifiers integrated for already, so Groth16 is one of them, you can say how many proofs you send per day or week or month or year, and then it'll show the sort of cost estimate comparison between just if you were doing that directly one by one on mainnet using current gas and ETH prices, versus if you used it through Aligned. So
that's awesome. No, that's a great effort. I'm actually quite curious to see that.
Yeah, it should be. Yeah,
This.
that looks like it.
That's great.
Yeah, this one here.
That's awesome. I'm a fan.
So yeah, this is just to try to help people understand how much they could potentially save and pass on to their users. And that doesn't look like it's not rendering properly. It's supposed to fill the whole box, but anyway, that's also good feedback for us. Like it doesn't look like that on my screen, but
I think I have some sort of like weird dark mode settings set. So
okay, cool.
Yeah.
And we are also, I mean, I guess Haleski is still down, but typically we're on testnet there. I don't know if we've redeployed to Sepolia. People can use us, run the line locally for testing purposes, but yeah. So I have another question about ZK email, which extends to this broader topic of ZK-TLS or web proofs, or the idea that we can authenticate and sign data from trusted servers and bring that on chain using proofs. So I'd love to hear your perspective on this, because it seems like you're kind of taking that approach, but you started off with a focus on email data that comes in a specific type of standardized format. But it seems like the same thing in a lot of ways.
It's similar. There's kind of like some nuances in how it's different. So ZK email, the nice thing about this is there's no centralized provider. There's no notary in the middle. There's no MPC. When people say ZK TLS, they actually mean MPC-TLS. Like what's happening is you're making an MPC key with a trusted notary or proxy, with a trusted notary in the TLS notary case. The proxy case is a little bit different. And you have to permission a set of notaries, because if a client at any point owns access to a notary, they can cheat the entire system. Like there's sort of a guarantee you have to say of, okay, with ZK-TLS or MPC-TLS, you can access more data, but you have to accept this notary assumption. Meaning, if you ever deploy an on-chain verifier, you have to permission these are the 5 notaries that are okay to make proofs. And I know that none of these will ever try to make a proof themselves on my system, or else it will be compromised. And similarly with the proxy scheme, there's no MPC now, but now the proxy is going to sign encrypted data passing to the proxy. But now again, you have to permission a certain set of proxies, because if a proxy is colluding with a user, they can then post arbitrary data onto your system. And so it's kind of like the approach we do with ZK emails. We want to remove all those points of trust. You never have to trust a ZK email team or a notary we run or a proxy we run or anything. As long as you have the email yourself, even if all of our infrastructure disappears tomorrow, your ZK email proof will still work. I think that's what makes this really exciting, is that this is why we can do stuff like wallet security with ZK email in a way that I don't think you can necessarily do with TLS notary or these kind of MPC-TLS solutions. Which is, and it's a trade-off, right? With ZK email, you have a more limited set of amount of data you can prove things about, only things in your email. With ZK-TLS, you can prove anything on the internet, but you accept this collusion assumption. And so it's kind of like different sorts of proofs for different sorts of settings. But it's a true point that they are both quite compelling, and often people don't understand the exact nuances of, hey, I'm accepting a slight, non-collusion hit in exchange for making proofs of more data.
Yeah. Oh, totally. I like that perspective. Thank you. It's been a very hot topic lately, and we're seeing a lot of adoption, it seems. Again, with trade-offs, there's some great examples from Opacity with I think Daisy, like this influencer marketing platform, where I don't think they're not verifying those proofs on chain yet, because their end users don't really care about that. They just want a server that can tell them that all these people did this action on TikTok or whatever. Which I guess makes sense, right? For their users, they're solving a problem. But then bringing this on chain adds more complexity, and I guess it's a question of how valuable these proofs are and how valuable the data is and what it triggers downstream, and how censorship resistant or decentralized or trustless you need it to be. You had something else in your slideshow also about a different type of data. It was one of the like this thing here.
Yeah.
And I missed the connection, like the email to this part.
Yeah, so the email to this part is basically like, kind of expanding the scope of, imagine we can, like, what data can we even make ZK email style proofs of? It wouldn't be an email proof exactly, but we would use all the same primitives and all the same circuits we've defined to do these kinds of proofs instead. And the idea is you can absolutely do that. Like, you can kind of say, look, like, as long as there is an asymmetric signature on that, we can make exactly the same kind of provenance proof and then exactly verify it with a line if you so want. If you actually go to that URL, you can see there's residents here. People tried to put up a bunch of these kinds of different proofs and they kind of succeed, and there's live demos you can try out. Where all these different teams sort of went in and is like, hey, like, this team verified the Japanese ID card and then built a wallet on top of that. This team built the kind of app testing where, okay, I can verify an app executed on my phone correctly, and now I can prove, somebody queried the location and camera APIs correctly. These aren't quite ZK email proofs, but they're proofs that provide the same kind of guarantees, but for a different kind of piece of data.
Yeah, very cool, very cool. I'm recognizing a lot of familiar names on this list as well.
Yeah.
And this happened last year, right?
This was last
signature.
year, yeah. Yep.
I remember seeing some messages about it and thinking it sounded very interesting. And now that I understand how all of this works a lot more, I'm like, okay, I need to go dig back into this, because I spoke with somebody from Anon Adhar, for example.
Yes.
And yeah, okay, cool. A lot of interesting stuff. So have some of the I think some of these projects have kind of progressed further, like ZK P2P, obviously.
Totally.
Cursive. Any others that people should maybe be aware of or that you're excited about?
Yeah, I mean, ZK P2P is still, I think at this point they've done 150K of volume on the email proofs, and their new system, like V2, has started already doing, like, I think in the first week it did like 100K of volume or something insane. So they're still going strong, still doing these permissionless on-ramp, off-ramping flows. Cursive is still doing really cool, exciting experiments with, kind of identity and cursive.team. And thinking about, hey, how can we combine ZK proof with PSI or witness encryption with these, like, kind of with FHE, with these weird cryptographic tools, but make them really intuitive for people, like it just tapping your phone onto a card or something. And all this cool cryptographic machinery is happening in the background, but you almost don't see it. It just enables new kinds of experiences, which is super exciting. They have a lot of cool demos. I think, Open Passport is now Self.xyz. They're doing the kind of passport verification where you can verify your digital identity, and they have a very cool kind of system where you tap your passport to your phone, and you can verify that you're a unique human being or that you're kind of over 18 or whatever it is. And they have a very exciting kind of system set up for that. So yeah,
Sweet.
a lot of these projects have evolved quite far, which has been really cool to see.
Yeah, no, definitely. I mean, I think there's a general sense that the industry we work in, crypto is changing, and the sort of building stuff for crypto natives only, like that era seems to be not winding down, but I think you know what I mean. It's like we're not going to grow the industry and onboard the next million or billion or however many people you want to put on your marketing copy, just by focusing on the crypto Twitter bubble, but by actually building real products and solutions for people, where a lot of this very interesting and useful cryptography that enables cool things like privacy is abstracted away, like real world applied cryptography on crypto rails. So this is all like super bullish.
I totally agree. I think it is quite exciting to see like this stuff hit more of the mainstream, because I think it will be quite important for the adoption of decentralized technology moving forward. I totally agree.
Yeah, like even this email thing, right? Like from a Sybil resistance perspective, of course, it's not perfect. Not everyone's going to have a passport, but with something like this, if people can understand why it's secure, and like I tried it myself, and like there's a little bug that I think I mentioned to you, but generally the whole process, the flow was good, right? Like it scanned my passport, it recognized the NFC chip in there, and if I could use that to, I don't know, unlock better matching on a Gitcoin funding round when I'm making donations, or
Totally.
access some kind of like under collateralized on-chain loan. Like that's all super, super, super cool stuff that I
No, I
think a lot of
totally
people
agree.
would like. HumanTech,
Yeah.
yeah.
Yeah, there's also, you know,
Are they
go
using
ahead.
ZK email somewhere in their stack?
They use very similar ZK tech. They actually used to use ZK email for one of their demos a while back. They did some account recovery stuff as well. I don't know if they still have ZK email production, but yeah, they're kind of HumanTech and Holonym are all doing very interesting things. Yeah, I'm
Yeah.
not sure they still have it in production, but at one point, yeah, we did experiment with them.
Yeah, they just acquired a Gitcoin passport
Yeah.
for their sort of Sybil product. And shout out to the HumanTech team, Shadi and Nanak. They're like some of the
Totally.
first people I met in crypto. Fun story,
Okay.
some lore is that I first went to ETH Denver in 2022, and that was on a travel grant through OpSci, the open science DAO that Shadi founded and was running. So Shadi, the co-founder of HumanTech, actually is a
Sick.
major reason why I am in crypto today, because he was like, hey,
That's
do you want to
awesome.
come organize some DeSci stuff? And I was like, yeah. And he's like, you should apply for this travel grant. And he covered my flight to Denver 3 years ago. And here
Awesome.
we are.
That's
So,
crazy.
yeah,
I
shout
love
out
to hear
Shadi.
that. It's actually cool. These are like real projects, it looks like.
Yeah, I don't know how active OpSci is anymore.
Okay.
But yeah, I remember that ETH Denver, they did a hackathon for like this, you know, it's what Holonym was and kind of became. And they were doing
Cool.
some, I think, threshold encryption stuff. And it really just, they kept building and finding things that they should solve using applied cryptography. And yeah,
Yeah,
I was
they're
really,
great. Yeah.
really happy to see what they're doing. Yeah, I think they're live on Symbiotic as well for like their restaking based security for what used to be called Mishti, but is now Human Network.
I see.
Yeah, it's an AVS. So yeah, cool. I'm
That's great.
glad you brought this up so I can chill.
No, yeah.
Shoddy.
There's lots of folks doing interesting things in this space. It's just that you kind of have to dig a little bit deep to kind of, you know,
Yeah,
to see all these experiments.
totally. And so one thing I wanted to say is when you're talking about the other types of cryptographic primitives that would be interesting to think about giving people access to by, you know, letting them sign their own data. So that's one thing. I mean, like with Align, like we've built the solution within a year for making verification of zero knowledge and validity proofs, making that verification on Ethereum very cheap and fast and very scalable, which we think for a lot of developers will be great because the security or trust assumptions required to just verify those proofs for low cost and put that on Ethereum probably makes sense. We have like a lot of restaked ETH backing us through Eigenlayer. But in general, we are thinking about how ZK and other types of applied cryptography primitives can be used to build better products. And we built Align because we want to build more stuff on top of it. So all of those ideas you had, I'm like, yes, this is all cool stuff for us to think about.
Yep.
And that's sort of where we're at. I mean, like on one hand, exploring different things that we want to build and figuring out where we should maybe focus our energy. Like what is the highest leverage product that our engineering and research sort of skills can be put towards. The other thing is we will be doing more hackathons where we try to help people. That should be the right Twitter.
I think it is, yeah, but something about my Mac Twitter app. Anyways, yeah, go ahead.
Yeah. So I mean, something like it'd be great. I guess we should probably wrap things up shortly, but down the line, it'd be really cool to collaborate for some hackathons. I think because there are.
I would love to. Yeah.
I have this GitHub page of different email ID or different ZK email ideas that I really want to go through, and I think that could be a fun way to get more people building with ZK. Like we've been trying to.
And building cool, useful
understand.
stuff like apps that people actually want to use. I totally agree.
Yeah. So, okay. Well, Jeannie, Yush, any other things that you wanted to add? I don't want to keep anyone too long. And I think we have a lot of good content and a lot of really interesting stuff to think about.
No, that's great. Yeah, this was fun.
It was wonderful. I hope I can get this presentation, or maybe, I don't know. We'll talk about it later.
Yeah, if you want the slides, the QR code is kind of right here, and you can kind of get the raw slides, which is cool.
Are you okay with me sharing this like on our Discord as well?
Yeah, go for it.
Okay, cool. I'm just gonna get a QR code scan of that because I think wrong one. I think there are people who will be interested in reviewing these. We had 439 people tune in total, which is pretty cool.
Awesome.
But
I hope people liked it.
Ooh, let's see if I can get this QR code. There we go. Yeah, I'm sure they did, and we'll get this up on YouTube as well and share that and send some clips over that you guys can post. So
yeah,
Yush, man, thank you again. This was a pleasure. Excited to keep the convo going and brainstorm more ideas.
Yeah, happy to be on. This is great.
Awesome. Okay.
Cool.
Bye, everyone. Thanks for tuning in. See you next week.
Cool.
Hey, okay. The stream is